Hi, I'm Larry Puckett, the DCC guy. Today, I want to show you how I installed a SoundTraxx decoder in a Stewart F3A locomotive. This particular project was the subject of my DCC Corner column in the January 2020 issue of Model Railroader magazine. So give me a minute here to set the camera up and we'll get started on how I did this. Before we do get started though, I want to remind you again about subscribing to the website. Hit the little red button here on the lower right hand side of the screen and you can click on that and subscribe. So we're closing in on 900 and hopefully by the end of the year, as I've said, we'll be up at 1,000. So let's go ahead and get started. This is the Stewart F3A that I'm going to work on today. Like I said, these have been around for about 30 years now. Well, they were released, I believe, in 1988, as I said in the magazine article. And they're a very good running locomotive, very smooth, very powerful. They have a lot of weight, and they can pull quite well. They're very easy also, as I'll show you, to convert to DCC. So let's go ahead and get the shell off to get started. The first thing you need to do is remove that front coupler where it comes through the pilot and prevents the shell from coming off. But once that's out of the way, and that's easy to do, I'll let you do that, just put your fingernails in underneath of the side skirt on each side here and pull outwards, and it should release the clips on the inside and slide right up. It very often, though, will catch like it just did for me. And there we go, it's off. So I'm going to set the shell aside. And so this is what we have to work with. Basically, the design used a very simple bronze wire that ran on each side of this light board here, and that sits on top of the motor. To go ahead and get this out of the way, we first need to release these pins here that go from each truck. These are the contacts for the track pickup. And then there's one on each truck here at the front and the rear on each side. So there's going to need to be removed. And that's a pretty straightforward process. You just release a little tension and those will slide right off there like this, as you can see. So they come right off the ends of that. And then the other thing that is involved here are these bronze or brass contacts that come up from the motor itself. So those go down and are attached to the motor brush contacts on the motor itself. So those will come out by simply lifting this spring a bit and at the same time sliding those out from underneath of it like that. Okay, so that pretty much releases these. Let's go ahead and get the screws off and get them out of the way and set those aside so that we don't lose them. We'll need them later in the process. Okay, so let me get that one out very quick, and then we just lift that up and out of the way. What we're left with then is the motor. It's a very efficient can motor. I believe it's a 5-pole skew-wound motor. Nice heavy brass flywheels in here so that you get quite a bit of momentum in here. And then the truck towers. Basically, if you look here, there's a small opening in the top of each one of these truck towers here. And that's a great place for injecting some of that white Teflon grease that I showed you in the previous video I did on lubricating diesel locomotives. So I always go ahead and squirt some of that down in there, and it'll get distributed into the gear train as I showed you before. Okay, so with the light board out of the way, we have these two wires on each side, one on each side of the truck, front or rear and front, that provide power from the right rail and the left rail, and the motor contacts here that go to the brushes. You can see this is a brush cover right here. So what we need to do then is take a look at the installation process. Okay, if we look at this with the decoder, the plug-and-play decoder in place, you can see that this wire is just not going to be long enough to reach to the point on the decoder where we need to solder it. So we need to make some changes here. The first thing we need to do here is cut off each one of these little clips and add a wire that will make these long enough. So I'm going to add a wire like this one right here to each one of these wires coming from the truck, just to make sure they're long enough to reach the decoder. So I'm going to get this out of the way, and we're going to switch to a different chassis that I've already done some work on, so that we don't spend the whole video watching me solder. So the first thing we want to do then is, as I've said, cut off those little clips and add wire extensions to each one. So you can see I've done these 3. This is one that still needs to be done. So it's zooming in a bit here so we can see what I'm going to do here. We have this one wire here that needs to be extended left. Okay, so I've pre-tinned this wire here, and I've pre-tinned the extension I'm going to add to it. So I'm just going to bring them right up against one another like so, and we'll solder those together. Now this type of splice is not what I showed you in the video on splicing heavy wires using what I called the Western Union splice, but this is adequate for this situation. It's not going to fail on you. So there, I've got that extension. Then the next thing I want to do is take a piece of heat shrink tubing, like this one right here I'm showing you, slide it over the end of the wire and right down over that splice that we just made there. Okay, and that is going to serve to protect our joint from shorts, and it's also going to give it more strength to keep it from breaking under flexing, because these do move a little bit as the truck moves. So we do want that protected somewhat. I'm going to just slide it down over the splice quite a bit. Then we'll take the tip of the soldering iron and just rub it on this heat shrink tubing, and that's going to shrink it in place. So it's going to stay put and give it added strength there. Okay, so that's all there is to that. Now, I've done that with all 4 of, let me go back out now. I've done the same thing with all 4 wires now, so we have these long enough to reach to the decoder. Now the other thing we need to do is add wires to these motor brush contacts like I've done on this one. So I've got one more to do here. You notice I've shortened this one a bit, and I'm pointing to the one. You can see I'm going to zoom in for you a little bit more. And if you look at this, you can see the area that I've already pre-tinned with some solder. It's shining right there. So then I'm going to take a piece of wire, and let me zoom out just a bit, and we're going to go ahead and solder this piece of wire to this contact right here, just like this, so that'll give us some wire to work with when we want to connect it to the connect that to the chassis or to the decoder. Okay, so this one is easy to do. You just reach down in here and that's all there is to it. So that's a good solder joint there. And then again, take a piece of heat shrink tubing and slide it down over that wire. And I will include in the description to the video the size of heat shrink tubing. Off the top of my head, I don't remember. I think this is 3/32, but I'll have to check. So we're going to slide this down because this particular wire or piece of metal goes all the way down along the side of this frame. So I want to make sure that there's no shorts in there. So I've got that in there in place, and everything is protected. Now we'll go ahead and shrink that down. And this is also going to strengthen this wire where it comes off of that bronze strip so that it's not going to break either. Okay, so now we've got the 4 wires for the track power pickup, and also the 2 wires that go to the motor. So let's go ahead and we'll add the decoder at this point, because I want to show you a couple of things here. Now, zoom it back out a bit so you can see. Now again, this is the SoundTraxx plug-and-play decoder. It fits right on top of this motor mount here, using the 2 screws that I took out previously. Now, I will tell you, this is the positive wire to the motor, and this is the negative wire to the motor. I know that because I've done a number of these installations, so it's pretty straightforward at this point for me to tell you which is which. So the one on the left is the negative, the one on the right is positive. And if you look close at this decoder, you will be able to see that this has M plus next to it, and this has M minus. These are the 2 motor contacts, so this is where the positive motor wire goes. This is where the negative one goes. So we need to run this wire across so that it's going to line up with that positive contact. Okay. The next thing after that we need to do is go ahead and get this decoder set in place. And it sets on top of this motor mount using the screws that I previously took out. Now, to prevent shorts on the top of the board, I go ahead and add a couple of these KD fiber washers. And just slide that over there, like so. And it sits right under the head of the KD, the KD washer sits right under the head of that screw. And then I'm going to drop that into place here and screw that one down. Okay, so that's going to get it started. And the washer is going to protect the top of that board. Okay, now we're going to want to do the rear one. So we get that lined up. Okay, I'm going to put a washer on this one, as I did before. Okay, and we get that put into place here, lined up with the hole in there. And I'm going to go ahead and screw that into place. Okay, so that's dropped down and into place now. And that fiber washer is going to protect any circuit traces there on the board. It's going to prevent any short circuits from developing over time with the head of that screw. And it's just a safe process as far as I'm concerned to go ahead and do that. Okay, so there we have the decoder in place. Now notice that this white microprocessor that's located on the board, that is located on the front end of the board. So it should be facing the forward end of the locomotive. And if you flipped over the board or looked at the instructions, they'll tell you that is the proper orientation. I've gone ahead and added solder to the contact pads on the board where we need to attach the power wires. So I'm going to go ahead and start soldering those into place. So first we'll do the right side here. Now if you want, you can run the wire up through this hole in the board. I have never found it necessary to do that. I just go ahead and solder these directly to it. I think that that hole works well if you're using the little black plastic clips that often come with these locomotives. And that's probably why the board is designed that way. Let me go ahead and get this soldered. There we go. Okay, that one's done. Now we'll go ahead and work on the front. Okay, make sure that you get these in the right orientation. Right one's on the right side, left one's on the left side. Okay, that's a pretty solid connection here, pretty solid connection in the back. Okay, so we've got those done in the back, the ones in the front. So let's go ahead and make the motor contacts. Now for that, obviously we're going to need to shorten things a bit. So let me go ahead and we'll go ahead and cut this a bit shorter. I'm not going to go overboard with it. I'm going to leave it a little because I've got to strip the wire off. So I'll put that like that, and I've cut it right that long, about 1/4 of an inch long. And I'll go ahead and I'm going to hold this with my tweezers while I go ahead and make this cut. There. And we'll go ahead and prepare this wire by adding a little bit of solder to it. Okay. Then we can solder it directly to the board. Okay, so I'm holding the wire right in place over top of the solder pad. And we're going to go ahead and just hit that with a little heat and let that melt into place. There. So that's the positive motor lead. Now we need to go ahead and do the same thing with this negative lead. Okay, so I'm going to go ahead and clip that a little shorter, expose some wire, and we'll go ahead and tin it. Like so. So now we got some solder there. Okay, so bring this wire down and position it right over the solder pad. And melt that into place. And there we have it. Okay, so now we have the motor pickups, as you can see here. And the basic installation is now done. Now one thing you can do, as I mentioned previously in my video on attaching keep alives, I'm going to widen this out a bit now. You can add a current keeper. These do have a socket here on the side where you can install a current keeper. And you can insert that in there, and then you can place it somewhere down here underneath of the or on top of the gear tower, or you can try to fit it up in the front. It's a little bit long for this, but it is possible to get it in here. One thing though that let me share with you, these really, I've never found these to need, or this particular decoder to need a current keeper or a keep alive or a stay alive of any kind. Now normally on other SoundTraxx decoders in the past, they've included this little electrolytic capacitor. I asked George Bogatuk at SoundTraxx recently why that is not included. And what he told me was that this board here is a fairly robust design, and it has enough capacitance on the board itself, and the hardware is adequate enough, that they haven't found a need to include one of these keep alive type capacitors that they used to provide with other types of their decoders. And I found that to be true, and an explanation why I've never found that I needed to add a keep alive to this particular type of decoder. So I'm not going to do it in this installation, and it's fairly straightforward in that respect. Okay, the final thing we want to do is add a, well, not the final, there's a couple of more things. The next to the last thing we'll do then is add a sugar cube speaker. So this is one, I think this is a Tony's Trains enclosure and speaker, 11 by 15 if I remember correctly. And you can see I've already added the wires to the contacts on the speaker. These are fairly small to work with, but I mean you can finesse this with a very fine tip. You do need a fine tip soldering iron like this one to be able to do this. And I think my March DCC Corner article in Model Railroader will deal with making these small solder connections to circuit boards and contacts like this one here. So this really is the most difficult soldering connection to make that I'll show you. Okay, so basically what I do is I just let this speaker float back here on top of the truck. And then these wires have to be connected up here. These are the two. I'm going to zoom in so you can see this better. Right here are the two speaker wires. There's an S plus and an S minus, and this is where these two speaker wire contacts are made, right here. So I'm adding a little bit of solder here to these speaker wire solder pads like I did for the power pickup wires. Let's go ahead and make these connections for the speaker wires. Got the first one in place here, and we'll go ahead and hit that with a little bit of heat. Okay. Make sure you don't have any stray wires sticking out there anywhere. And then we'll do the second one here. Okay, now that takes care of the speaker. Okay, so it's sitting back here out of the way on top of the gear tower on the truck. The next thing we're going to want to do finally is add a headlight for this. So what I did for this article was I used a small surface mount LED. You can see it right here. And that's how, I mean, these things are very tiny, but it's bright. I'll show you this in a second. I got these off of eBay from a supplier in China. And as you can see, it came with a 1000 ohm resistor already attached. And the wires were already attached. So I haven't had to do any soldering at all with this. The one thing I did was I took and bent it up at a slight angle, and I'll show you why in a second. But I want to show you first how bright these are. This is a 9-volt battery, not 12 volt. Okay, so I'm going to hook this up temporarily and hold it with my finger, hopefully, long enough to show you just how bright a light you get with these little boogers. And you can see it doesn't have any of that blue tint to it that you get with a lot of these LEDs. Matter of fact, it's a very nice white light. So it's good for these diesel locomotives. And it's great because these things are cheap. I think I got 20 of them for about $4 or $5 from the fellow in China. And that included shipping as well. So I can recommend these. Look for golden glow or golden light or something of that nature. You want the golden ones. You want to make sure that you do not get the ones that have that bluish tint to them. Or orange, or any other strange colors. Okay, so here is the shell that I'm using for this, you see. I'm going to take this little light, and I'm going to attach it to the rear of this lens that's already in the locomotive. So the easiest way to do that is with a drop of super glue. So let me get my super glue out and we'll go ahead. I like to use this Loctite super gel. It's a very nice gel form of super glue, so it doesn't run all over the place. And it has a nice squeeze applicator on the side so that you can squeeze on that and it will squeeze out a little drop at the tip here. So I'll show you that here. Just a drop comes out at the tip. And that's all you need is a little bit on it. And then I'm going to take that like so and place it down here, right the rear of that headlight casting. There. And hold that long enough for it to set up, which is going to take a few seconds. Okay, while that super glue is setting up, let me zoom out and show you the next part. Now, you need to be able to stabilize this little thing in place so that you're not going to pull it out every time you remove the shell or while you're maneuvering it. What I use here is this blue stick from DAP. There's also a black version of this, black stick and blue stick and all kinds of other things. And what it is, it's an adhesive that comes in this little stick form, and you can just pinch off a piece of it and pull it off of here, like so. I'm going to put this right here at the point where the wire comes back through this little projection, and you'll see what I mean. It's where the light tube originally was located. Okay, so as you can see here, I've put a bit of that blue tack putty in here to hold the wires in place and protect the LED from being pulled out inadvertently. Okay, so the other thing I'm going to do is I'm going to take some of this Kapton tape and I'm going to use it to stabilize the wires here inside the cab. Make sure I didn't get any. There we go. Okay, so we'll get that in there and press it into place to hold these wires down in the top of the shell. And now we have the light in place and the wires running back. So let's make the connection on the decoder itself. So what I'm going to do is turn this over. Now, on the decoder, these two solder pads up front here are for the headlight. And the one on the right is positive, the one on the left is the negative. Okay? So now what I want to do then is go ahead and make these solder connections to those. So as I said, the one with the resistor in this particular LED is positive. So I'm going to go ahead and solder it down to the positive. Like so. And we'll bring the negative lead up and solder it in place. Okay, so that should be everything. And as you can see, we have our speaker sitting back here in the rear. All the connections are made to our motor here and here. Track pickup wires here and here, front and rear. Okay, so that's all there is to it. Then carefully maneuver these wires into place and just let everything slide down. Now, at this point, it's ready for a test. Now, because of all the wires that I've connected, I'm going to place this on a current limited programming track for its initial test run. And then after that, I'll show you it running on the layout here on the Piedmont Southern. Okay, here we are on the Piedmont Southern in Monroe Yard. I've tested the locomotive on the programming track and there were no problems. I reprogrammed it to an address of 4. Another thing I want to point out, this decoder has an output, sound output, rated at 2 watts, whereas the Sugar Cube speaker I used is only rated at 0.8 watts, which is about 40% of that maximum value. Consequently, you multiply 0.4 times 255 and you get a value of about 102 for your master sound control level. So I went ahead and reprogrammed that output to a value of 100. So that way the Sugar Cube speaker is going to be protected. It's never going to go above 0.8 watts output. The other thing then is to adjust your sound levels for your horn, your bell, whatever else, relative to that value. So you can go up to 100% for the horn and still be protected, since the maximum sound output, the master, is set at a level just slightly less than what these Sugar Cube speakers are rated at. Okay, I'm going to go ahead and start her up and we'll listen to her sounds. Okay, you can see she started up. We'll go ahead and turn on the headlight. Okay, now the bell. Nice, clear, crisp bell sound there. And the horn, I've set it for a Nathan M5. That's a little bit louder than I'll probably have it set for in use. Okay, let's go ahead and crank her up and you can hear the prime mover. It's not going to increase in RPMs because I'm not going to get above the number of speed steps necessary for it to crank up to the next level. But let's get her going. Nice, even, smooth speed control. That's at speed step 2. I'll go ahead and start increasing a little bit. And we'll stop. Okay, let me go ahead and put that into reverse and we'll back it up a bit. She's ramping down. Now I'm going to go ahead and hit the F6, which will shut her down. You can hear the shutdown sequence. Okay, that's all there is to it. I hope that gives you a better feeling for how easy a project it is to install one of these SoundTraxx plug-and-play decoders, especially in the Stewart Bowser F units. It doesn't take a lot of soldering skills or a lot of experience in doing this. Give it a try and keep coming back for more. Thanks a lot and have a good one. Bye.